Hi guys, welcome back. For this video, it's gonna be all the assignment about chapter 5. Let's start with the first one. Suppose a random sample of n equal to 16. Measurements is selected from a population with mean and standard deviation. For each of the following values of mean and the standard deviation, give the values of mean of sampling distribution and standard deviation of sampling distribution. So first we have to find the mean, and then we can find the standard deviation of sampling distribution. For A, from the last video, mean of sampling distribution is equal to means of populations. So here will be 14. For B will be 196. For C will be 28. And for D is 14. And then for standard deviation, to convert from normal standard deviation to standard deviation of sampling distribution, we need to use standard deviation divided by square root of n. For A, the standard deviation is 3 and n is 16, so it's square root of 16, which is 3 over 4. So it's going to be 0.75. And then for B, the standard deviation is 16 and divided by square root of 16, which is 4. Next is 28 divided by square root of 16, which is 7. And then 96 divided by square root of 16, which is equal to 24. Let's move on to the next one. Find the mean and the variance. So, to find the mean, we need to use this formula, sigma x times p of x. And for the variance, we can use it by sigma of x, or the given value, minus mean square times p of x. So let's start with the first one, which is mean. So mean is equal to 1 times 1 over 3 plus 2 times 1 over 3 plus 5 times 1 over 3, which is equal to 1 over 3 plus 2 over 3 plus 5 over 3, which is equal to 8 over 3. So 8 divided by 3 is equal to 2.667. And then for the variance, we're gonna use this given value, subtract the mean, and sum it together and square and times p of x. It's gonna be 1 minus 2.667 square times 1 over 3 plus 2 minus 2.667 square times 1 over 3 plus 5 minus 2.667 square times 1 over 3. This will equal to 2.889. Let's move on to the next one. Show that x bar is an unbiased estimator for mu. So find the mu and the x bar. So mu is sigma x times p of x. So from here, mu is equal to 1 times 0.3 plus 2 times 0.2 plus 3 times 0.2 plus 4 times 0.1 plus 5 times 0.2. This will equal to 2.7. And then to find this one, we will use the same strategy, which is x bar times p of x bar. So it's gonna be 1 times 0.09 plus 1.5 times 0.12 plus 2 times 0.16 plus 2.5 times 0.14 plus 3 times 0.2 plus 3.5 times 0.12 plus 4 times 0.09 plus 4.5 times 0.04 plus 5 times 0.04. And this will equal to 2.7 also. So from here it's going to be 2.7 and here it's going to be 2.7. So this is unbiased because E of x bar is equal to mu. As we learned from chapter 5 part 1, if x bar is equal to mu, is unbiased. So here it's going to be yes, since E of x bar is equal to mu. And the B part is find the variance of x bar. To find the variance of x bar, we're gonna use sigma of x bar minus E of x bar, or the mean of x bar, square and times the P of x bar. So from this it's gonna be 1 minus 2.7 square times 0.09 plus 1.5 minus 2.7 square times 0.12 plus 2 minus 2.7 square times 0.16 plus 2.5 minus 2.7 square times 0.14 plus 3 minus 2.7 square times 0.2 plus 3.5 minus 2.7 square times 0.12 plus 4 minus 2.7 square times 0.09 plus 4.5 minus 2.7 times 0.04 plus 5 minus 2.7 square times 0.04. So these will equal to 1.105. So let's move on to a last one. Suppose a random sample of n is equal to 632. Measurements is selected from a binomial population with probability of success p for each of the given values of p. Give the mean and standard deviation of the sampling distribution of the sample proportion p hat. Complete part A to C below. So, as we learned, the mean of the sampling distribution proportion is gonna be this one. P hat is equal to P. Since P hat is equal to P, for the A is gonna be 0.1. The mean for the B is gonna be 0.5. The mean for the C is gonna be 0.8. And then the standard deviation. The standard deviation of the sampling distribution of proportion is going to be square root of p times q divided by n. So when p is 0.1, q is equal to 1 minus 0.1 divided by 632 square root. So these will equal to 0.012. And then b, this will equal to square root of 0.5 times 1 minus 0.5 divided by 632, which is equal to 0.0199. And then c is going to be square root of 0.8 times 1 minus 0.8 divided by 632 is going to be equal to 0.016. Okay, that's it for today. The next video is going to be the assignment from midterm and the past final. I will see you in the next video.